we want to stop here to talk about the black rock that's over there, especially that you can see where it's black and that little pinnacle out that way. That black rock is the diabase sill again, and that's inside the Bass limestone. You can see a little bit of the Bass limestone right in here. So we saw the same thing as we entered into the Granite Gorge this morning, and the asbestos mine was right at the top of that diabase sill. So we got the same thing going on here. The diabase, which is an igneous rock, a liquid rock, chemically reacts with the Bass limestone to make the asbestos. And William Bass was down here mining the asbestos. He wasn't quite as successful as John Hans was. But anyway, we want to stop here because this is one of the about 4 or 5 locations and 4 or 5 different rocks that Andrew Snelling and Steve Austin have dated in the Grand Canyon. Austin started off just by dating some of the lava flows, the Cardenas, and some of the lava flows that we'll see downstream. But Andrew Snelling, he had quite a bit more money, research money, to do his dating, and he went all out here. So he collected a sample of the diabase, actually a couple different places in there. And in radioactive dating, there are about a dozen different methods that you can use, but he chose 5 of the most common methods for radioactive dating. He did potassium argon, rubidium strontium, samarium neodymium, and some lead, uranium lead methods, and lead methods, and a couple different variations of all those. But he sent that rock out to the laboratory, and in fact he actually divided the sample into about 20, and he sent each of those 20 pieces to the lab for dating. And radioactive dating is kind of expensive. It's not it's not pocket change when you send a sample in and have it analyzed. But anyway, with all those 5 different methods that he used, he got 5 very distinct dates. The dating methods agreed with themselves, so every time he sent in a samarium neodymium date, for example, it came back, very close to the same. But when you take other dating methods, and that dating method will come back as a very different date. And one of the things that Dr. Snelling discovered with this process is that the heavier the isotope, in other words, the heavier the element on the periodic table, the greater the number on the periodic table, the larger the radioactive date would be. And he has no idea, or nobody really has any idea why that seems to be the case. So this was, in my opinion, a really classic study to demonstrate the unreliability of radioactive dating, because how old is that rock? We got 5 very different radioactive dates we could select from. And maybe that's even the wrong approach. Maybe, how about none of them are wrong? Or none of them are right.
Were they all millions of years?
They were, but how do you know which one is right, if any of them at all? So I had a student just presented this paper at the most recent International Conference on Creationism, and he looked at the 30,000 radioactive dates that are in the U.S. Geological Survey database. And he found a similar thing. Guys have collected different rock samples from all over the United States, dated them with different methods, and put these into that database. And he compared radioactive dates when there were 2 or more different dates recorded for different rocks. And he found the same thing, that when you have different dates, different dating methods for the same rock, it will often yield anomalous date. And so in my opinion, when you get a radioactive date, it's the age that you get's an interpretation. It may not be the correct age, and in my opinion, it probably is not the correct age. And you know, you would think if you date the same rock, it wouldn't matter the dating method. You should get the exact same age. This has been demonstrated in other places as well. As some of you remember, Mount St. Helens erupted in 1980. There was a lava flow that came out in 1986. That lava flow is dated with potassium argon dates, and the potassium argon dates were all over the place, from several tens of thousands of years old to about 500,000 years old. And the rock was only 10 years old. So, and we've dated lava flows from Hawaii and Vesuvius and other places where we actually know the historical age. We know the date on the calendar when that lava erupted, and yet many of those lava flows already have dates of millions of years. And so it shows us that there's something terribly wrong with the assumptions and the radioactive dating methods. So that's just one of the rocks right there. That's the diabase sill. Same sill that we saw up at Hans Rapid. But Dr. Snelling actually collected his samples up that slope right there. Questions? It's awful hot up there.
Not about that, but can you explain why the granite is all kind of, it's going up basically, or the granite and the...
Yeah, this, believe it or not, this black stuff is actually granite right here. It's not our schist anymore.
Oh, it's not.
But this
Okay.
is the greatest unconformity, this flat surface right there. That's the greatest unconformity. The great unconformity is up there. So this is that Precambrian supergroup in here.
Oh, okay, okay.
That vast limestone being
Yeah.
the lowest
Okay.
on up. So.
But why, I guess my question is, why is the granite sort of going up? No, meaning, why is the direction of the rock seemingly up rather than sideways like the other rocks we see?
I don't know what you mean by going up.
The vertical jointing instead of horizontal.
Now, like in your diagram,
Like in
you've
here
got
by
all
the
these
river?
layers like this, and then under the great conformity, they go at an angle. So
Yeah.
they seem to be more vertical, or at least diagonal, as opposed to
up there at
flat,
the
like
top, you mean?
pancakes. No, down here.
Down here?
That's just
They're
erosion,
joints.
isn't it?
It's just, they're just cracks in the rock.
They're just cracks.
Yeah.
So they weren't really laid down, they're just
No.
there.
Yeah, the cracks develop. One way crack develops is the canyon gets excavated quickly. The rock relaxes, and as the rock relaxes, this stuff gets pulled out of here really fast. The rock relaxes, and you get like vertical joints like this one right here.
Okay, okay.
And they're parallel to the canyon.
Okay, okay,
So
got it.
it's called exfoliation.
Okay.
Yeah.
Kind of like our
And
skin.
then, when you were showing us at that last stop, the dike of the granite going through the schist, am I saying that right?
Yes.
Yeah. So, and my understanding is you were saying that's because the granite was hot and molten and it was
Yeah.
shooting up.
Yep. The
So,
molten-
what do you think? Is that like the third day of creation
Likely.
that was happening?
Likely.
Okay.
A whole bunch is going on then, I think. Yeah.
Is it similar to like when a volcano has molten
Yes.
a lot and goes up?
Yes, and the way you think about all those light-colored dikes and sills that we've seen, penetrating through the dark rock, the way to think about that is that enters those cracks explosively, like bang, and that liquid rock is fired up right through there, and then it cools pretty quickly as well. I often go in the fall, go to a big geology conference, usually take my students as well. And one year I was kind of bored and not knowing what session I should go to, and I just thought, I'll just pick one at random and walk in and see what they're talking about. And I did. And the guys were talking about, granite dikes and intrusion of granite dikes. And it's a conventional conference, and I was hearing them say that these dikes cool quickly, and then they define what quickly meant, and I would like clean my ears out and like, what did you guys just say? There's been a real paradigm change in the past years about how fast these igneous dikes intrude, and then again how fast they cool. Some people are saying and publishing some of these things are cooling within minutes, and in that time making really big crystals and so on. So it doesn't take an extraordinary amount of time. At least that's the current thinking on that. All right. Are we gonna? Yes, the great unconformity is the Tapeats. The easiest place to see it is over there. The Tapeats is right at the top. Over here, and the great unconformity would be right below it. This one right here would be the greatest unconformity on top of the granite. No, this is granite right here, Bass limestone above it. Yep. Yep. Waterfall play? You guys like to go play in a waterfall?
Yeah.
All right.
Yeah.
All right.